All right, I'm going to talk to you about exponential expanded form and standard form of exponents. So exponential form, well, that's pretty much anything with an exponent. So it can be something like -3 to the positive second. If it has an exponent, it's exponential form. Or it could be something like this, 1 over 4 as the base to the third power. Okay, so as long as it has an exponent, that is exponential form. Expanded form is when you take the base and you expand it out however many times the exponent says. So I'll use the top two examples from above. So if I'm going to do -3 to the second power, that's telling me to take -3 as the base and multiply it by itself 2 times. So that's what it would look like in standard form. And likewise, 1 over 4 to the third, I would take 1 and I'd expand out the 4 to the third. So 1 over 4 times 4 times 4. And both of those are examples of expanded form. Standard form is the solution or the answer. So -3 times -3, a negative times a negative is a positive. And over here, 1 over 4 times 4 times 4 would be 1 over, and then I multiply out. What's 4 times 4? Well, that's 16 times 4 is 64. So these are examples of exponential form. Just remember, anything with an exponent is exponential form. Expanded form, you take the base number and you expand it out however many times the exponent tells you. And standard form is just the answer, the regular number. So let's look at some examples. All right, so we have 2 to the 5th form, 2 to the 5th power. Okay, so 2 to the 5th power is exponential form. So because it has an exponent, if you want to expand it out, you take the base number and you multiply it out by itself 5 times. And then standard form is when I take and I multiply this all out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right, so that is what the difference between exponential, expanded form, and standard form is. Now let's look at a negative exponent, like 3 to the -3rd. Okay, so a negative exponent does not have anything to do with being a negative number. It has to do with it being a reciprocal, which means that when you see a negative as an exponent, here, that is telling you that the numerator is going to be 1 and the denominator is going to be 3 times 3 times 3. You can also think of 3 to the -3rd, and this is still the exponential form. You can rewrite that as 1 over 3 to the positive third power. And then we expand out that denominator. So 1 to the -3 power, or 1 over 3 to the third power expanded out, is the same thing, 1 over 3 times 3 times 3. And when we get to the standard form, it's 1, and then we multiply out that denominator. Well, 3 times 3 is 9, times 3 is 27. All right, I'm going to do one more example. let's see, what if I had a negative base number and a negative exponent? All right, so that's exponential form. Now, anytime I have a negative exponent, that is going to be 1 is the numerator, and the denominator is the base number, which happens to be negative 5, to the positive third exponent. Both of what I have written here is exponential form. When we expand it out, it becomes 1 because we have a negative exponent, and then we expand out that base number. So this is negative 5 times negative 5 times negative 5. All right, and now we get to standard form. 1 is still our numerator. Now negative 5 times negative 5 is positive 25. Positive 25 times negative 25 is negative 100. I don't think I said that right. Negative 5 times negative 5 is positive 25 times another negative 5 is negative 125. So we have all three versions here, all three forms. Negative 5 to the negative third is exponential form, or you can rewrite that, which is also exponential form, as 1 over negative 5 to the positive third. When you expand it out, it's 1 negative 5 times negative 5 times negative 5. And then standard form is when you multiply all those denominators together to get the answer. All right, I have another example here. 2 to the negative fifth. So again, exponential form is still 2 to the negative fifth. Now we can rewrite that into, that's the equal sign. We can rewrite that to 1 over 2 to the positive fifth. They are equivalent. They're both exponential form. When we expand it out, as long as we have a negative exponent, we're going to expand out and put 1 in the numerator. 2 times 2 times 2 times 2 times 2. And then we're going to do the standard form by multiplying that all together. 2 times 2 times 2 times 2 times 2 is 32. So this becomes 1 over 32. Okay, what if we have negative 5? So we have a negative base, and we'll do a negative exponent as well. So in expanded form, that's going to be 1 over, take our base and multiply it out 2 times. And then our standard form is when we simplify. So that becomes 1. A negative 5 times a negative 5 is a positive 25. What if we did, well, I already did this one, but I'm going to do it again just to show you the difference. Negative 5 to the negative third. So that's 1 over negative 5 times negative 5 times negative 5. Now when we multiply this all out, a negative 5 times a negative 5 is positive 25, times another negative 5 is negative 125. So you have to be really careful with your negatives and positives. Remember that a positive times a negative when we're talking about the bases here, a positive times a negative is a negative answer. A positive times a positive is a positive answer. A negative times a negative is also a positive answer, which is why we got a positive for the first example, because a negative 5 times a negative 5 is a positive 25. But a negative times a negative times a negative gives us a negative. All right, I'm going to go through some problems from the quiz here. Write the expression in standard form. Okay, standard form, that is the answer. So 2 to the 5th power would be the same. This is in expanded form. And then you're going to multiply each of these out. And you would get 32. Okay. Write this in standard form. So again, that's the answer. So because it has a negative exponent, that tells me that the standard form is going to have a 1 in the numerator. And the denominator is going to be the base number, 5, times itself 3 times. Now what I've written here is expanded form. The question asked for standard form. So then standard form is 1 over 5 times 5 times 5 is 125. Yeah. All right, moving on. Write the expression in standard form. Well, to the 0 power, any number to the 0 power equals 1. It doesn't matter if it's a million to the 0 power. It doesn't matter if it's negative 8 to the 0 power. It doesn't matter if it's a half to the 0 power. It equals 1. Write the expression in standard form. Okay, so again, standard form is the answer. Well, okay, so let's pick this apart. We have a negative exponent. So that tells me that my numerator is going to be 1. My denominator is going to be negative 9. So I take the base number and multiply it by itself 2 times because my exponent is negative 2. And when I multiply this out, negative 9 times negative 9 is 81, positive 81. Negative times a negative is a positive. Write the expression in standard form. Okay, so we have negative 1 to the negative 4th power. Okay, so what that means, it's a negative exponent, so my numerator is 1. My denominator, I take the base number, multiply it by itself 4 times. Okay, so a negative 1 times a negative 1 is a positive 1. Times a negative 1 brings us back to negative 1. And then we have negative 1 times negative 1 equals positive 1. So this answer you can write as 1 over 1, or you can just write 1. They're both equivalent. Write the expression in expanded form. All right, now, expanded form, you don't have to multiply anything out. Expanded form, we have a negative exponent. So we're going to start with a 1 in the numerator. And our denominator is going to be 11 times itself 5 times. Notice it's positive 11, not negative 11. Look at that base. It's just positive 11. So we're going to have 1 over 11 times 11 times 11 times 11 times 11. And that is written in expanded form. Which of these is another way to write 2 to the 6th power? All right, so these are both positive. 2 to the 6th power just means the number 2 as a base multiplied by itself 6 times. So that answer would be this top one. What does 3 to the 2nd plus negative 5 equal? Okay, so 3 to the 2nd is 3 times 3, which is 9. Now we have 9 plus a negative 5. 9 plus negative 5 is the same thing as 9 minus 5, which is 4. If you wanted to use the number line, you'd start at 9 and you'd subtract 5 from it, which brings you to 4. Oops, I skipped one. What's another way to write all these 4s multiplied by themselves? All right, so we have 4, and we're going to count them. 1, 2, 3, 4, 5, 6, 7. So that would be 4 to the 7th power. Same thing here. Our base is 9. 1, 2, 3, 4, 5, 6, 7, 8. So that's 9 to the 8th power. Pick the equivalent of 4 to the negative 4th power. All right, I'm going to give you a test-taking strategy here. Anytime it says pick all, then apply, select all, your answer is going to be more than one. Otherwise, they wouldn't say select all. Okay, so let's take a look here. We have 4 to the negative 4th power. Well, this negative exponent tells us that the numerator is going to be 1. All right, now I'm going to take a look. I'm going to extend out my base and see if any of these match. So that would be 1 times over 14 times 14 times 14 times 14. Okay. Take a look. All right. So 14 to the 4th on the denominator would match this. It can't be b. I don't have any negative numbers because remember, a negative exponent is not a negative number. And again, that would be that one's not right, because if I look at all my 14s multiplied together, no, it's this one right here. Because if you did 1 to the 4th power, or 1/4 to the 4th power is the same as what we have here. It's going to take me forever to do this. 1/14 times 1/14 times 1/14. That's a 4 over 1/14. So the answers were A and C. A and D. Select the equivalent of 2 to the negative 3rd power. Okay, so we have a negative exponent. So our numerator has to be 1. Our denominator, before I even look at the answers, our denominator is going to be that base number of 2 multiplied by itself 3 times. Okay, I see one that matches right here, C. Now b has -2 times -2 times -2, which is not correct because our base is not -2. Our base is +2. It's only our exponent that's -2. Our exponent that is negative only means that we're going to put a 1 in our numerator. All right, everyone was pretty good at this one. Pick the right options for the drop down below. All right, 5 to the 4th power. 5 is called the base. And 4 was called the exponent. All right, write the expression in standard form. So that's the answer. Again, we're looking here. We have a negative exponent. What's that tell us? 1 is the numerator. The denominator is going to be that base number multiplied by itself. Now the base number is 10. Multiplied by itself 2 times. It asks for standard form, so I need to multiply that out. And 10 times 10 is 100. So this answer would be 1 over 100. Write the expression in expanded form. I don't need to multiply anything out. I'm just taking that base number, which is 3, and multiplying by itself 7 times. I don't need to spend the energy multiplying that out. That is not what it's asking. It's only asking for expanded form. Pick the equivalent of 5 to the -2nd power. Ah, look at that. Pick all that apply. So that's going to be more than 1. All right, so we're going to take a look here. We have a negative exponent. That tells me my numerator is going to be 1. My denominator is going to be this base number multiplied by itself 2 times. All right, so I'm going to put this in standard form just so we can see if we have any that match. Right, so, all right, it's not -25 because I don't have a negative here. These 1 over 5 times 5 and 1 over 25, none of those are negative. All right, how about, it's not E, it's not 25 because it's 1 over 25, so I can eliminate that one as well. C will match. And again, 1 over 5 times 5 is the same as taking 1/5 times 1/5. And if you don't believe me, you can multiply that out. 1 times 1 is 1. 5 times 5 is 25. So the other option would be D. C and D. One over 6 to the 2nd power is considered to be in which type of form? Wow, let's look at this. Look at that 2. That 2 is an exponent, so this is exponential form. Standard form would be if we multiplied that out. 6 times 6 is 36. Expanded form would be if we expanded that denominator to be 6 times 6. In math form is just made up. I don't know. That's not anything. I just made that up. The answer is B. What does 2 to the -4th equal? Again, See a pattern here. Negative exponent. Start with 1. Your denominator is equal to 2 to the positive 4th power. So let's expand this out. So 1 over 2 times 2 times 2 times 2. That's a 2. All right, let's put this in standard form. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, now that I have all my forms written out, I'm going to find one that matches. And here it is. Oops, I missed one. Select the equivalent expression to negative 3 to the 3rd. Okay, so this exponent is positive. It's not negative. It's positive. So what we're going to do is take this base of negative 3 and just multiply it by itself 3 times. It doesn't have 1 in the numerator because the exponent's not negative. It's positive. So negative 3 times negative 3 is positive 9 times another negative 3 would be negative 27. And that answer is B. And last question. Any number raised to the 0 power is 0. That is false. It is not 0. It is 1. And I addressed that a little bit earlier with the problem when it said 8 to the 0 power. Okay. All right. So turn in this assignment. Go back to Google Classroom. Turn it in. And in the comments, please indicate which day you would like to retake this quiz. It'll be during your lunch period on an in-person day, and we can make arrangements. So put that information in the comments, and good luck. Thank you.